Hi guys, welcome back to the shop. Hey, today I'm going to do another cylinder boring operation, and in doing so I'm going to do something a little different. This is how my milling machine is usually set up. It's a glorified drill press most of the time. I've got a heavy vise on it, I've got a drill chuck on it, I've got drills up there, all stuff, because that is normally what I do. I do more drilling than anything. But I'm just going to go let the camera run a little bit and let you see what all has to go into this before you can uh, bore a cylinder. You've got to tram the head. Otherwise, you're making the relationship between the spindle this way and the table this way and this way zero. That's what you want. So it takes a little time to get the vise off, to tram it, to get ready to do this, and I just want to go through a little bit of that so you understand that it's not just a wham bam thank you ma'am. There's a lot more to it than just putting the cylinder over there and the boring head on and going to it. If you do that and you forget that you had the head trammed one way or the other, or not trammed, but you had it angled, then you're going to mess up a man's cylinder. So anyhow, I'm just going to let the camera run a little bit and let you see that. And I'm going to talk a little bit about the specific relationship between the cylinder and the piston, the way that the manufacturer, in this case Suzuki, looks at that clearance, and how to measure it, why they want to measure it that way, and some of the problems that it can cause. And just like all the rest of my cylinder boring ops, the honing is just, that is a project all of its own. I just don't have enough time to include it into one of these. It would be a 2-hour thing, and that would take forever to get up on YouTube. And I don't know whether they'd even allow 2 hours or not. Anyhow, I'm going to split that up just like I always do, because that in itself is the meat and potatoes of this whole procedure. If you don't get the clearance right, there's no purpose in doing this at all, because you're going to have problems as this gentleman did here. And we're going to cover that a little bit. We're not going to beat a guy up because where he took it, and and them maybe not taking the amount of care that they should. But some things just happen, and it happens to all of us. It really does. I make mistakes, other people make mistakes, and we just have to live with it. And if we have problems, we've got to make those mistakes right. But anyhow, I'm gonna go over this in more depth in just a moment. But first, I'm gonna let the camera run a little bit while I get the milling machine ready. First off, we're just going to get all this extra stuff off here that we don't need. And get the vise off. This vise in itself is pretty heavy. I've got to find a place to put it before I start. One thing I always have to make sure of too, you never know what you've dropped or what's happened here. So what I do is I take a Arkansas stone and stone the top, at least where I'm going to be working. Just make sure I don't have any dimples. You'll feel them right away if you run onto one, and it feels good. So if you've got a little high spot somewhere on there, then when you put the cylinder down, it will cock it up one way or the other, and you don't want that. Okay, now I'm tramming the head here. I've got a dial indicator in here. I've got it set on 0, the front. And as I come around, I've got about 1,000ths back here. And I'm good front and back, but I've got a little bit, about 1,000ths in the table this way. So I will have to work on that. You can see this, the head of it tilts right here. So this goes this way, and it also turns right here, so it goes this way. So that's how I've got to go in here and take and adjust that. Okay, so we're trammed out and we're zeroed out here, and we're not going to move it. I've got it centered here, otherwise it's centered here, and centered this way back and forth. So I'm not going to move it from there unless I need minor adjustments when I'm getting ready to, when I'm using the indicator to center the cylinder. That's the only time I'll move that. So we're ready to start setting up. Okay guys, let's take a look at this. One thing you want to make sure of before you go to setting anything up is to make sure you're flat here. You know, reasonably. You can't be perfect, and there's not a whole lot you can do about it unless you are willing to go to a lot of expense. But what I do is I take my light, put it behind there, and I can just kind of take a steel rule and just look at and see what kind of distance I've got underneath. And you just do that in all directions that you can. You know, sometimes people will go after the gasket with one of those roll-lock discs on a little grinder, and you know, if you're trying to get some gasket material right here, you're getting in there with that. This is so soft, so you can actually hog out part of that, especially on an edge like this. So really, you don't want to ever do that with those roll-lock grinders like that. The best thing I found is on these is a Motion Pro makes a little gasket scraper, and they have two different tips. You've got a steel, maybe even carbide tip one, and then you've got a brass one, and you just change your tips on them. These are very sharp, and you can resharpen them too. And you just go along here on the, use the brass one for your aluminum, and you can get underneath and get rid of whatever stubborn gasket material there is there. There's a lot of gasket scrapers out there, and there is a carbide one made by Lyle that's a pretty awesome one also. But I find this is really good on aluminum because the brass is comparably as soft as the aluminum, so you're not going to tear up anything. Anyway, this one was cleaned up pretty good and shouldn't be a problem. Okay, now what we need to look at here is the measuring and how Suzuki, all the manufacturers are a little different, but you just need to pay attention to what they tell you to do. And when they're telling me to check this cylinder, this one here, they're telling me to measure the cylinder from the top of the cylinder 0.79 inches or 20 millimeters from the top right here. So, and you know, it doesn't have to be ridiculous. I mean, I'm at 20 millimeters plus one there, but I'm not sure whether you can see it or not, but it's just about, a half inch or so, probably not even that, 3/8 of an inch from the exhaust port. And I've got it marked there with a little Sharpie. Maybe I'll highlight it a little bit more just so we can tell. And the same with our piston. Actually, on this one, they're saying 23 millimeters or 0.91 from the bottom. And I've got it marked right here with a Sharpie. That's where we measure from. So that's our relationship. It's not between here and here. It's between here and here. So it's just, you've got to pay attention to where they want you to measure it at, or you can end up with a lot of noise that you just, you know, you can say, well, let's just go by the center of it. We'll call center here and the center on the piston. That's not going to work. You've got to do what they tell you to do. Now, there's some rules to, if you have absolutely no data, there's other things that you're going to have to do. And usually it is about a ½ inch from the bottom of the skirt and about a ½ inch down. But, you know, the distance here is, or not the distance, the thickness here, as I've said before, is way different than this one here. You know, you can, there may be 10 thousandths difference. Now we always measure this perpendicular to the pin. Okay, so if you, we'll try to stay away from the rings there. So I'm getting 5610, let's say, millimeters there. And we go down here to about that area, and we're at 5642. So we're, you know, there's a substantial difference between the two. So, you know, the manufacturer has, through a lot of testing and verification, have determined that the expansion is going to be more here because of the heat generated from the spark plug sparking right here all the time, and this is it's got more mass than this does here. So they've taken all that into account. So this part of the piston is going to grow more, but it's going to take longer to do that. You know, it may take 30 minutes to grow, to actually seat these rings the way they should be seated. That's why they're rings. They give. But anyhow, just pay attention to where they want you to measure, and that is where you're going to compare your numbers. You're not going to compare them, both of them here and both of them here. Your comparison is going to be from here to your mark here. And the only way to do that is with a dial bore gauge or a snap gauge. You can do it, and I think I've shown you before how you can do that with a snap gauge, and you get pretty consistent readings, but you're not going to get better than you're going to get with a dial bore gauge. And one thing I've done here since the last time is I've changed out my shaft. I've got the shorter one in here now because I just don't do automotive cylinders much anymore. So this is where we're at, and this will give us a little more comparison. But as I've told you before, I set this up in a setting fixture from the same manufacturer that manufactures the gauge, and I have this already set up for the what did I do with it here? The dimension. I may have to find that. Anyway, I've already set it up to the size of the piston, but we're going to measure that again. And again, we're just make sure everything's clean. Clean your micrometer, and I've just recently verified all this equipment, I think, on the last one I bored. So we're going to measure right about here at this point. All right, we're at 2 inches, 0.221 is where we're at. That seems like that's what I remembered before. Let me jot that down. 2.221. And I've already set my bore gauge up to that, and I can verify it on the micrometer also. kind of difficult to do, but you can do it. Right there. So I'm zeroed out at 2.221 that I put into my checking fixture. And then we're going to go down here and we're going to check at our mark. And we're right there. We're at 3 and about 7/10,000ths. So 3 and 7/10,000ths, almost 4 thousandths at the point in which they tell us to measure. And that's measuring here, this measurement. That is what I dialed into the dial bore gauge. So, you know, Suzuki is telling us that we want a piston cylinder clearance of 1 and 8/10,000ths to 2 and 1/10,000ths. And that's where they want it to be. We're almost double that. So that is, this, if it's only got 30 or 40, 50 miles on it, whatever, it just wasn't done to the right spec to start with. And I believe that's where his noise is. And there's another reason. That is in the ports. When I go in here to feel these ports, they just feel like razor blades to me. So they need to be chamfered, and if they're not, the rings are going to hook on them, especially if it's loose to start with. And even the top here, it's just like a razor blade up here. So, you know, you've just got to be careful when you're doing this and get the right measure at the right place, and when you're done, finish the job. And that's chamfering the ports. We're not going to beat up anybody over this or anything. You know, everybody makes mistakes. I do too. And I hope that I don't make one here, but it's, I know what the manufacturer is telling me to do, and that's what I'm going to do. So Yamaha, they're not quite as specific, but Suzuki is. And I think that they know they've got a problem because they do all this isolation with the rubber. And it seemed to me like as the engines got newer into the 70s, the late 70s, early 80s, they got a little bit more noisy. And if you didn't have this stuff on there. And I think that was probably part of the reason, whether it was the manufacturing process, different metallurgy, I don't know. I don't know anything really about that kind of stuff. But we're going to bore this and we're going to set it up to the manufacturer's specifications, and I don't think he's going to have the noise that he has now. Okay, I'm getting her kind of centered up here. It's not too bad. Look, I'm getting a little further away. Okay, let me get it under power. Getting a little closer there. Closer yet. I think we better stop right there. That looks good. This is what takes the time. Okay, pretty much set up. We're zero. The only one that should change is this one as I go up and down to put in another tool or set that. Everything else should remain at zero. Okay, we're taking our first pass here. Looks good. Consistent all the way around. This is after the first pass. And what's really strange is you can see it started cutting here. Here at the top. So we know we're centered. But as we get down to just above the intake ports, it doesn't hit until the bottom. So that's really strange for just a few miles. Second pass. Probably going to clean that up. I expect it will. 2000s. Okay, this is after the second pass, and you can see that just around the intake ports, it's clear, it's cleaned up at the bottom, and it's cleaned up at the top. So, and then the rest of it is cleaned up all the way around. You know, I'm just thinking, I'm trying to figure out what would have caused that, because that's indicative of wash from many, many, many miles. But that's, you know, it'll clean up in the next pass, I believe, but it's just that it's just around the intake ports. So I'm just wondering if, you know, I'm just thinking here, I'm not blaming anybody, but I'm just wondering if it was worn beyond what the first over would clean up, and they just called it a day and honed it, because this is a lot more wear, and it's just around the intake ports. That's the only place, and that's, like I say, that's indicative of fuel wash with many, many miles. I don't know, just thinking. We take our next pass through. Couple more thou. Okay, take another 2. Probably going to take 6 yet to do it, so 2 more passes after this. You can take a lot more than I do, but I just take a little at a time. I'm not in any hurry. And you know, if you crowd it, you're liable to end up getting a tool bit stuck in a port or something, and that would be catastrophic. So just take your time and that way everything will be okay. Everybody's in a hurry these days, don't have to be. I don't know whether I mentioned it or not, but we're going to 1 millimeter. It was already at 0.5 millimeter. So let's see, what is that? A total of 40 thousandths. So it'd be 20 thousandths this pass, or this bore, or thereabouts. It's cleaning up real nice. You can see the tool bit coming out the sides there where the cylinder is, the transfer ports are. Just about to the bottom. There's the automatic shutoff on the down feed. It's looking real nice. Should be getting pretty close. I'm going to lower it down, check my piston again. Should be good. Get you handheld here so you can get a better view of the bore. That's just where I just brought it up. I won't do that when I get to the last one. Of course, it doesn't matter anyway. You're going to hone it out. Okay, she's cleaned up everywhere and looking real nice. Let me try my piston. Let me clean that edge just a little bit. I just don't like to scratch my piston. Yeah, a couple more thousandths probably. I like to get it just above the pinhole out there. That's usually where I go, and then I finish it up by honing. Okay, looking pretty good. Dial in a couple more. Alright, our bit's looking good. Alright, let's take another run. see where we're at now. Yep, I like that. Okay, let's get it out of there. Yep, looks good. Okay, guys. There we are, we're done. Try to keep it so it doesn't blind you. Okay. And what our new piston measures is, this was the old one, the one with rings on it. And we're measuring it where we're supposed to. Okay, 2.2423. Okay, I'm gonna set that up in my board. Okay, I think this thing kind of glares a little bit, but I'm set up at exactly the 2.2423, and I'm zeroed out on my gauge. Okay, and then I come over to my micrometer and see if I can. Like, it's pretty close. It's real hard to hold. There it is. So the same, pretty close to the same reading within 1/10,000ths. So we come over and we're going to check our bore now. Okay, so we're about 4.5 thousandths smaller than our piston right now. Let me get down there where I'm supposed to be. Now, not quite. Are you getting that? Yeah, almost 4,500 smaller than the piston right now. So that's what we're going to hone out. So we've got, we need to go basically 6,500 thousandths on the hone, because that we're 4.5 almost smaller than the piston now. Plus we got to put our clearance in. So about 6 thousandths, a little over, is where we've got to go. So that'll be for another day, of course. But I think this is going to make a big difference for him. It really bothered me that it had so much, after my first and second pass, the bottom and the top on the intake side had metal removed, but from about here to about here didn't. And like I said before, that is indicative of, this big area here, that's indicative of fuel wash with a cylinder that is well used, not 50 miles. So I don't know what happened, but there was a lot of there was just a lot of extra space right here. I'm talking clearance in this area, and you put that along with the razor sharp edges of the piston, the ports, and I think that is probably what led to all the noise. Okay guys, there you have it, another cylinder board. I don't know whether people are getting tired of seeing these or not, but I'm throwing them up anyway. My regular viewers, I think, are watching them, but most of the cylinder boring stuff that I do, there's a lot of other people watching them. So I'm going to continue to put them up until they don't, I guess. But it's not what everybody wants to see, I know, but it is interesting if you have never seen it done before. Well, anyway, we've got about 6.5 thousandths to hone out of this thing, and that gives us, we can go at a snail's pace and just hone it, check it, hone it, check it, hone it, check it, until we're at our measurement. I believe it's 2 thousandths, or 1/8 to 2 thousandths, and I like to go on the high side if I can, just the high side of the tolerance, not over 2. A lot of people do, I think, go over 2 because they don't have control over how people are going to ride them, or break them in or not break them in, or whatever. So they're not wanting a seizure, so they give it a little extra, and that actually takes a little life out of it. But just be careful with them for the first 100 miles, or maybe a little more than that. You just got to baby them, and they'll serve you well, and they will run for a good long time. All right, thanks for going along on the ride, guys, and we'll see you next video.